Hello everyone. So coming to one more session. In this session I am going to explain about a problem in the chapter of chemical equations based on the mole concept. Once you observe this problem, the problem is calculate the amount of aluminum is required to get 1120 kilograms of iron by the below reaction. So already they are given the equation. So within the problem there is a equation. So no need to worry about the equation. In case if they are not given the equation, what is the condition? Let us assume in this reaction they are not given equation. So the reaction between aluminum and iron. So according with your 10th class syllabus, where we get this concept? So we'll get this concept under the chapter of principles of metallurgy. In this chapter, a thermite reaction is there. Under the concept of thermite reaction, so aluminum is reacting with metal oxide and produce that respective metal. That concept is there in the chapter of principles of metallurgy. So from that chapter, this equation was taken, and based on this equation, this problem was created. So already equation is given, no problem. Along with that equation, they are also given the values of aluminum, iron, oxygen, atomic weights also given, provided. So to do this problem, first we need to balance the given equation. So the equation is aluminum plus Fe2O3 gives rise to Al2O3 plus Fe. In the problem, that equation is unbalanced. But before going to the calculation, before doing the calculation, we need to balance the chemical equation. Why we need to balance the chemical equation? According to law of conservation of mass, the mass of reactant should be equal to the mass of the product. If we did the problem without balancing the chemical equation, the values are wrong. So that we need to balance the equation first. So according to that, if we balance the equation, we'll get the final balanced equation is 2Al plus Fe2O3 gives rise to Al2O3 plus 2Fe. After balancing the chemical equation, we have to observe the coefficients of each compound, each substance in the equation. So in that equation, if you observe, we can understand that 2 moles of aluminum is reacting with 1 mole of iron oxide Fe2O3 and produces 1 mole of aluminum oxide and produces along with that 2 moles of iron. So we can understand that by seeing that equation, by seeing that balanced equation. So according to problem, they are asking calculate the amount of aluminum is required. So if you observe that equation, I was kept aluminum and iron in box. That means that, so here there is no concept of limiting reagent. We can do directly by comparing with aluminum and iron. Okay. So according to equation, 2 moles of aluminum produces 2 moles of iron. So 1 mole aluminum weight is nothing but its atomic weight, gram atomic weight or gram molecular weight. So atomic weight of aluminum is 27. So in that reaction, the aluminum is 2 moles. So 2 into 27, that is nothing but 54 grams of aluminum. 54 grams of aluminum can produce 112 grams of iron. How can we say this thing? Based on the equation. According to that equation, it is clear. 54 grams of aluminum can produce 112 grams of iron. Now the question is, how much aluminum is required to produce 120 kilograms. In the problem they are given kilograms, but based on the equation we are doing in grams, so that we need to convert that kilograms into grams. If we convert how much aluminum we required, we don't know. So that X grams of aluminum is required to produce 1120 into 10 to the power of 3 grams of iron. If you do the cross multiplication, we'll get the answer. So the final answer is 540 kilograms. So to produce 120 kilograms of iron, the required aluminum is 540 kilograms. This is the way to do the problems. So to do this type of problems, the steps are very important. So first you need to write the chemical equation. Then after you have to balance the chemical equation. Then after you identify this reaction, does it has any limiting reagent or not. If there is a limiting reagent, we need to compare with the limiting reagent. So limiting reagent is important in the formation of product. So here there is no question of limiting reagent, so it's easy to do that. So hope you can understand this problem. So once you understand this problem, try to do without seeing to get more perfection. Thank you.